Hello everyone, welcome back to my YouTube channel. Myself Grishma, I am pursuing my BE in Sri Venkateswara College of Engineering. Today's course title Mathematics for Computer Science, course code BCS 301, topic Binomial Distribution. Exploring binomial distribution, real world applications and statistical insights. Introduction. Binomial distribution was discovered by James Bernoulli in 1738. This is a discrete probability distribution. A discrete probability distribution applicable to the scenarios where the set of possible outcomes is discrete, such as coin toss or a roll of dice, can be encoded by a discrete list of probabilities of outcomes known as probability mass function. What is binomial distribution? The word binomial literally means two numbers. A binomial distribution for a random variable x, known as binomial variate, is one in which there are two possible outcomes, success and failure, for a finite number of trials. Note that however we define success and failure, the two events must be mutually exclusive and complementary. That is, they cannot occur at the same time, mutually exclusive, and the sum of their probabilities is 100%, that is complementary. Definition of binomial distribution. If x is a discrete random variable probability mass function, binomial distribution formula P of x n c x p x 1 minus p, which is q, to the power n minus x, where x is 0, 1, 2, 3, 4 and q is 1 minus p, then x is a binomial variate and the distribution of x is called binomial distribution. P of x equals x, which is equals to ncx into px 1 minus p, that is q to the power n minus x, where x is number of success and random variable x. C is the combination of x success for n trials. P is probability of success. 1 minus p, that is q, is probability of failure. N minus x is number of failures, where pq should be greater than 1. P plus q is equals 1 because probability cannot be more than 1. X is a discrete random variable which may take on only countable number of distinct values, such as 1, 2, 3, 4. Assumptions for binomial distribution. For each trial, there are only two possible outcomes on each trial. S and F. S is success, F is failure. The number of trials n is finite. For each trial, the two outcomes are mutually exclusive. P of S is a P is constant and P of F equals Q equals 1 minus P. The trials are independent. The outcomes of trial is not affected by the outcome of any other trial. The probability of success P is constant from trial to trial. Probability distributions. An example will make clear the relationship between the variables and probability distribution. Suppose you flip a coin 2 times. This sample statically experiment can have 4 possible outcomes, that is HH, HT, TH and TT. Now let the variable x represent the number of heads that result from this experiment. The variables x can take on values 0, 1 or 2. In this example, x is a random variable because its value is determined by the outcome of statistical experiment. A probability distribution is a table or an equation that links each outcome of a statistical experiment with its probability of occurrence. Consider the coin flip experiment described above. The table below, which associates each outcome with the probability, is an example of probability distribution. Number of heads 0, where probability is 0.25. Number of heads 1, where probability is 0.50. Number of heads 2, where probability is 0.25. Definition. A binomial experiment is a probability experiment that satisfies the following condition. The experiment is repeated for a fixed number of trials, where each trial is independent of other trials. There are only two possible outcomes of interest for each trial. The outcomes can be classified as success or as a failure. The probability of success P of S is same for each trial. The random variable x counts the number of successful trials. Notation for binomial experiments. Symbol n. Description. The number of times of trial is repeated. P is equals to P of S. Description. The probability of success in a single trial. Q is equals to P of F, the probability of failure in a single trial, Q is equals to 1 minus P. X, the random variable, represent a count of number of success in a trials X equals 0, 1, 2, 3. Basic probability concept. Experiment. Any operation or process that result in 2 or 3 outcomes is called as experiment. Example, tossing a coin is an experiment or trial where the outcomes head or trial is unpredictable. Random experiment. Any well-defined process of observing a given chance phenomena through a series of trials that are finite or infinite, and each of which leads to single outcome, is known as random experiment. Random experiment is different from experiments under controlled conditions because the observation in random experiment involves a chance phenomena and not performed under controlled condition. Example, drawing a card from a pack of 52 cards. This is also chance phenomena with only one outcome. Possible outcome. The result of random experiment is called an outcome. Example, tossing a coin and getting head or tail up is an outcome. Event. Any possible outcome of random experiment is called event. Performing an experiment is called trial and outcomes are termed as events. Simple or elementary event. An event is called simple if it corresponds to a single possible outcome. Example, rolling 2 dice, then the event of getting head or tail. Sample space. The set of aggregate of all possible outcomes is known as sample space. Example, when we roll a die, the possible outcomes are 1, 2, 3, 4, 5, 6. Thus all outcomes 1, 2, 3, 4, 5, 6 are sample space, and each possible outcomes are element in a sample space called sample point. Favorable event. The number of outcomes which result in happening of desired event are called favorable cases to the event. What are probability distribution? A probability distribution is a table or an equation that links each outcomes of a statistical experiment with its probability of occurrence. A discrete probability distribution specifies the possible values of random variable and the probability that each outcome will occur. Probability distribution. To understand probability distribution, it is important to understand variables, random variables, and some notation. Variable is a symbol a, b, x, y, etc. that can take on any specified set of values. When the value of variable is the outcome of statistical experiment, the variable is random variable. Generally, statisticians use a capital letter to represent random variable and a lower case letter to represent one of its value. For example, capital X represents the random variable. P of X represents the probability of X. P of capital X equals small x refers to a probability that the random variable equal to particular value denoted by a lowercase x. As an example, equals 1 refers to the probability that random variable x. Random variable. The mathematical rule or function that assigns a given numerical value to each possible outcome of an experiment in a sample space of interest. Discrete random variable. Continuous random variable. Mean, variance, and standard deviation. Although you can use the formula learned for mean, variance, and standard deviation of a probability distribution, the properties of binomial distribution enable you to use much simple formulas. They are on the next slide. Population parameters of binomial distribution. Mean mu is equals to np, variance equals npq, standard deviation equals square root of npq. Mean, variance, and standard deviation. Let's calculate the mean, variance, and standard deviation for the sports bike inspection. There are relative simple formula for them. They are all titled hard proof, but they do work. The mean or expected value is mu equals np. For the sports bike, mu is equals to 4 into 0.9, which is equals to 3.6. So we would expect 3.6 bikes out of 4 to pass the inspection. Makes sense really. 0.9 chances for each bike times 4 times equals 3.6. Variance equals 4 into 0.9 into 0.1, which is equals to 0.36. Standard deviation equals square root of 0.36 equals 0.6. Finding mean, variance, and standard deviation. In Pittsburgh, 57% of the days in a year are cloudy. Find the mean variance and standard deviation for the number of cloudy days during the month of June. What can you conclude? Solution: there are 30 days in June, so that n equals 30, p equals 0.57 and q equals 0.43, that is 1 minus p. You can find mean variance and standard deviation. Mean: mu equals np, where n is 30 and p is 0.57, we get answers 17.1. Variance equals n into p into q, that is 30 into 0.57 into 0.43, which is equals to 7.353. Standard deviation equals square root of npq, which is equals to square root of 7.353, gives the answer as 2.71. Conclusion: the binomial distribution is a discrete probability distribution used when there are only two possible outcomes for a random variable, success and failure. Success and failure are mutually exclusive, they cannot occur at the same time. The binomial distribution assumes a finite number of trials, n. For binomial distribution to be applied, each successive trials must be independent of the last, that is, the outcome of previous trial has no bearing on the probabilities of success on subsequent trials. Thank you for watching my video. Please do like, share and subscribe.